Hello everyone, good morning to all. Myself, I am Sravani, working as Assistant Professor in the Department of CSE, Mlritm College, Dundigal. So today our concept is greedy method. Greedy method is one of the algorithm problem solving technique. The main goal of greedy method is to select optimal solution. So it is the main goal of greedy method is to select optimal solution. So the main solution of this to build step by step process to choosing best or optimal solution. So the main problem of greedy method is to solve optimal problem. What is meant by optimal problem? Optimal problem, we are given set of constraints and optimal functions, solutions that satisfies all the constraints, then it is called as feasible solution. The feasible solution for which the optimization function has the best value is called optimal solution. So let us consider one example. So minimum cost spanning tree from a weighted connected graph. So already I told you, so we are consider constraints and optimal functions. So in this minimum cost spanning tree, constraints are every time a minimum edge is added to the tree, and adding of an edge does not form a simple circuit. So feasible solutions are the spanning trees for the given graph. Optimal solution means spanning tree with minimum cost among all the spanning trees. So in this example, this is my graph. So I am consider 4 vertices A, B, C, D. A to B weight is 2, A to C weight is 3, B to D weight is 1, C to D weight is 2. The feasible solutions are the spanning tree of the graph G. Those are, first one is, so what is meant by spanning tree? Without forming a cycle, right? So here in the above graph, these are the feasible solutions. Total how many solutions? 4 solutions. So C to D, why C to D edge is missing? So to form a cycle. So discard that edge. So next second one is A to B is also weight 2, but it also forms cycle. So remove that edge also. In third one, so B to D cost is 1. So to form a cycle, so remove that edge. Next, A to C weight is 3, but it also forming a cycle. So remove that edge. Total how many feasible solutions are obtained? Total 4 possible solutions are obtained. So in these 4 possible feasible solutions, best one is called as optimal solution. Among these 4, which one is minimum weight? So fourth diagram is minimum weight. Total weight is 5. So first one is 6, second one is 6, seventh one is 6, third one is 7, fourth one is 5th. Among 4 feasible solutions, best one is fourth diagram. So that is the optimal solution among 4 feasible solutions. So greedy method mainly focusing on 2 properties. First one is greedy property, second one is optimal structure property. Areas of applications of greedy method is job sequencing with deadline, knapsack problem, minimum cost spanning tree. There are 2 algorithms used to find minimum cost spanning tree. First one is Prim's algorithm, second one is Kruskal's algorithm. So last one is single source shortest path problem. First application of greedy method is job sequencing with deadline. So in this problem, we are consider n jobs. So each and every job is associated with two properties. First one is each job is contains two properties. First one is weight, second one is first one is profit, second one is deadline. The main objective of job sequencing with deadline problem is to earn maximum profit. We will earn profit only when job is completed on or before its deadline. That is the main goal. So to earn profit on or before job sequencing deadline, okay, we assume that job will be taking unit time to complete. So let us consider one example. Here I am consider 5 jobs. 1, 2, 3, 4, 5. Job names are J1, J2, J3, J4, J5. I already told you each and every job is associated with deadline and profit. J1 indicates job 1. J1 deadline is 2, profit is 60. Job 2 deadline is 1, profit is 100. J3 profit is 20, deadline is 3. J4 deadline is 2, profit is 40. Next, J5 deadline is 1, profit is 20. So here we are consider 5 jobs. Each and every job is deadline and profit. So step 1. Arranging all the jobs in decreasing order based on their profit. So in previous we are consider profit, right? So based on that profit, arranging all jobs in decreasing order. So job, deadline, profit. In previous, which profit is highest one? So 100. So that is the J2, deadline 1, profit is 100. Next, which one is next highest one? 40. That means J4. So next one is J4. Sorry, next one is 60. So next one, J1 having next highest profit, right? So next one is J1, corresponding deadline is 2, profit is 60. Next highest one is J4, right? Next one is J4, corresponding deadline is 20, profit is 40. Next highest one is, both are 20. So in this case, we are consider first in first out manner. So we are consider J3 first. J3 deadline is 3, profit is 20. Next one is J5, deadline is 1, profit is 20. Step 1, arranging all the jobs in decreasing order based on their profit. Step 2 is find the maximum deadline. That means we are consider which deadline is highest one. So 3 is the highest maximum deadline. So we are consider maximum deadline is 3. So we are consider 3 slots, 0 to 1, 1 to 2, 2 to 3. Total how many slots here? 3 slots. That slots are based on which criteria? Which deadline is highest? That we are consider that deadline is maximum time slots. Okay, right? Next, assigns jobs to the latest possible free slots. So here first one is J2. Corresponding deadline is what? Corresponding deadline is 1. So we are consider one formula, R minus 1 comma R. In this case, R is nothing but deadline of corresponding job. Corresponding job indicates which job we are consider first? J2. Why J2? So arranging all the jobs in which manner? Decreasing manner. So that's why we are consider J2 first. So J2. So what is the deadline of J2? So 1. So what is the value of R? R equal to 1. What is the formula to allocate jobs in corresponding time slot r minus 1 comma r. So 1 minus 1 comma, what is the value of r? 1. So 1 minus 1 is 0, 0 comma 1. So in 0 comma 1, we are assigning which job? So J2. So corresponding profit is, what is the profit of J2? So 100. So J2 is 100 plus. Next, which job is we are consider? J1. Corresponding time slot is 2. So R equal to 2, R minus 1 comma R. 2 minus 1 comma 2. 2 minus 1 is 1 comma 2. So next 1 to 2 slot is assigned to which job? J1. That means J1 is allocated before 2. Before 2 means 0 to 1, 1 to 2. But 0 to 1 is already allocated to J2, right? So here we are consider J1 is 1 to 2 time slot. Next, we are consider next job is 2. Next job J4. So J4, what is the value of R here? 2, right? What is the formula? R minus 1 comma R. What is the value of R here? 2. Why 2? J4 deadline is 2. So that's why we are consider R value is 2. 2 minus 1 comma 2. 2 minus 1 is 1. 1 comma 2. Is it free slot 1 comma 2? No, that is already allocated to J1. So 1 to 2 means we are consider 0 to 1, 1 to 2. So deadline of J4 is 2. So we are consider 0 to 1, 1 to 2. But 1 to 2 already allocated to which job? J1 job, right? So next we are considering next 0 to 1 is free or not? No, it is already allocated to J2. So J4 is neglected. Why? Because that time slot is already allocated to J4, J2 and J1, J4. So this one is rejected. Okay, next consider J3. What is the deadline of J3? Deadline of J3 is 3. In this case, what is the value of R? R equal to 3. What is the formula? R minus 1 comma R. What is the value of R? 3. 3 minus 1 comma, what is the value of R? 3. 3 minus 1 is 2, 2 comma 3. If it is free or not? 2 comma 3 slot is free. So allocate J3. So first assign J2. Which slot? First slot. Next assign J1. Which slot? Second slot. Next J4. Slot not possible. Why? Because 0 to 1 is already allocated to J2. 1 to 2 is allocated to J1. So J4 is rejected. Next assign J3. Which slot is allocated to J3? Third slot is allocated to J3. Is there any other time slot? So J5 is not possible because there is no time slot, right? So total profit of J2, J1, J3 is first J2 job. Profit is, what is the value? J2 profit 100. J2 profit is 100. So 100. Next J1. What is the profit of J1? J1 profit is 60, right? So consider 60 J1. Next profit is J3. So J3. What is the corresponding J3 profit? 20. 20. Total is 180. So total maximum profit is 180 for this example. So next, second application is fractional knapsack problem. Okay. So knapsack is nothing but bag or container. In this, items are placed into the knapsack. Knapsack is nothing but bag or container. Items are placed into the knapsack. Each and every item is associated with profit and weight. Each and every item is associated with weight and profit. The main goal of this knapsack problem is items or objects are placed into the knapsack. But one constraint is there. not exceed the limit of the knapsack. You know that each and every container contains some capacity, right? So items are placed into that knapsack, but not exceed the limit of the knapsack. So in this also, we are main goal is to earn total profit value is maximum value, right? So let us consider the main algorithm is, consider one example, like, so in this example we are consider total 5 objects or 5 items. Already each and every item is two properties. First one is weight and second one is profit, right? First item weight is 3 kgs, profit is 10 kgs. Second item weight is 3 kgs, profit is 15 kgs. Third item weight is 2 kgs, profit is 10. Fourth item weight is 5 kgs, profit is 12. Fifth item weight is 1, profit is 8. So we are consider 5 items here. So consider all the items and their weights and profits. Next, here main one is consider capacity of that container. So in this example, capacity of that container is 10 kgs. That means this bag contain 10 kgs, right? So next step. So calculate P by WI ratio. PI is nothing but P indicates profit, W indicates weight. PI indicates, let us consider first object. That means what is the value of P? P1. We are consider second object. Consider P2. Next, we are consider third object. We are consider P3, right? Like that. W1 means weight of first item. W3 means weight of third item. Like that, we are consider PI, WI. Second step is calculate PI by WI ratio. In this example, so PI by WI ratio. So first, PI by WI ratio. So we are calculating first item PI by WI ratio. What is the PI? 10. 10 by 3 equal to, what is the value? 10 by 3 equal to 3.3. So what is the value of P by WI ratio of first item? 3.3. Like the second item. Second item, what is the profit? 15 by WI. Second item is 3. 15 by 3 is 5. So PI by WF second item is 5. Next, third item. 10 by 5 equal to, what is the value? 10 by 2 equal to, what is the P by WI ratio? 5. Next, fourth item. 20 by 5 equal to, 20 by 5 equal to 4. P by WI ratio of fourth item is 4. Next, fifth item. 8 by 1 equal to, what is the P by WI ratio of fifth item? 8. So this way calculate PI by WI ratio. Okay. Next, arranging these items in decreasing order based on their PI by WI ratio. Next step of algorithm is decreasing order. So arranging all the items in decreasing manner based on which criteria? PI by WI ratio. So items. And so previously we are calculating, right? So what is the, which order we are consider? Decreasing order. Based on which criteria? P by WI ratio. Which one is highest one? So here. So these are the PI by WI ratio. Which is highest one? So 8. Corresponding item is 5. So first placed 5. Corresponding weight is 1. Profit is 8. P by WI ratio is 8. Okay. Next. Which one is next highest one? So here 5. Second item profit P by WI ratio is 5. And third one is also 5. So in this case, we are considering first in first out manner, right? So consider second item, right? So second item corresponding weight is 50, 3, profit is 15, P by WI ratio is 5. So here consider 3, 15, 5. Next highest one is 3, 5. So which 5? Corresponding item is 3. Next place 3. 3. Okay. Corresponding weight, profit, P by WI ratio is 2, 10. Sorry. 2, 10, 5. 2, 10, 5. Next one is, which one is highest one? So 4. Corresponding item is 4. Next place 4th. Next which one is highest? Next one, which one is highest? First item. So first item. So this way, arranging all the items in decreasing order based on their P by WI ratio. Now we are ready to place the items into the knapsack. So what is the main condition? Without exceed the limit of the knapsack. That means limit of the bag. Okay. So first, which item is placed? Fifth item is placed. Fifth item is placed into the knapsack. So what is the weight of the first one? 1 kg. Right? So total in this example, knapsack capacity is 10 kgs. Right? So 10 kgs. 10. First item is, we are consider 1 bag, right? So total we are having how many items? 5 items, right? So first we are consider first item. First item, what is the weight of first item? 1 kg. So our bag capacity is 10 kgs. Our item weight is 1 kg. So 1 kg is possible to load into the 10 kgs bag? Yes, it is possible. So first item 5 is placed into the knapsack bag. So fifth item is placed into the knapsack bag. So what is the remaining capacity? 9 kgs. Why 9 kgs? In example, they are consider knapsack bag is 10 kgs. Why 9 kgs? Already one full item is placed into the knapsack. What is that item weight? 1 kg. 10 minus 1 is 9 kgs, right? So next, which item is placed into the knapsack? Next, second item is placed into the knapsack. So second item. What is the second item weight? 3 kgs. Okay. Our bag remaining capacity is 9 kgs. Is it possible to 3 kgs item is placed into the 9 kgs bag? Yes, it is possible. So which item is placed? Next, second item is also placed into the knapsack. So 9 minus corresponding weight of second item is 3. What is the remaining capacity of knapsack? 6 kgs, right? Next, we are consider third item. Okay, third item weight is 2 kgs. Our remaining capacity of bag is 6 kgs. Is it possible to 2 kg item is placed into the 6 kgs bag? Yes, it is possible. So we are placing third item into the knapsack. So third item into the knapsack. So what is the remaining capacity? 6 minus 2 equal to, what is the value? 4. What is the remaining capacity of our knapsack bag? 4 kgs, right? So next, checking fourth item. What is the weight of fourth item? 5 kgs. But our knapsack remaining weight is 4 kgs. Is it possible to 4 kg item is placed into the 5 kg item is placed into the 4 kg bag? No, it is not possible. So in this case, we are consider fractional. So fifth item, 4 by remaining capacity of the bag by, what is the weight of the fourth item? 5. 4 by 5. Okay. So in this part, we are consider fourth item. Not fully, we are consider 4 by 5. That means 0.8% item is placed into the knapsack. In which item? Fourth item. Not fully placed because there is no weight. Remaining capacity is only 4 kgs. But remaining capacity is only 4 kgs. But our fourth item weight is 5 kgs. There is no possibility of 5 kgs item is placed into that knapsack. So that's why we are consider fractional 4 by 5. Okay, right here 4 by 5. Is there any other spaces? There is no remaining space in that bag. So reject which item? Last, fifth item, first item. So we are consider in maximum value. How to calculate maximum value? What is the formula of this one? So pi into xi, sigma of I equal to 0 1 to n pi into xi. Okay, so pi is nothing but p indicates profit, x indicates item is fully added into the knapsack or not. So first, which item is placed into the knapsack? So first, fifth item is placed into the knapsack, right? What is the profit of this one? 8. So 8 into x1. So fifth item is totally added into the knapsack, right? So we are consider 1. So 8 into 1 equal to 8. Next one is, which item is placed into the knapsack? Second item. Second item profit is 15, right? So 15 into, so second item is fully added into the knapsack. Yes or no? Yes, it is fully added into the knapsack. So we are consider 1. 15 into 1 equal to 15. Next, which item is placed into the knapsack? Next, third item is placed into the knapsack. Is fully added? Yes, it is fully added. So what is the profit of third item? 10. 10 into 1 equal to, what is the value? 10. Okay. Next, here fourth item. Fourth item is not fully added into the knapsack. It is only 0.8 kgs only added into the knapsack out of 1. So here we are consider, what is the profit of fourth item? 20 into, what is the value of this one? 4 by 5. So 5 4s 20, 4 4s 16. Totally 37. So 8 plus 15, 23. 23 plus 10, 33. Sorry, 23 plus 10. So here, this is the maximum profit we are consider, right? So next application is minimum cost spanning tree. So in this, we are consider 2 algorithms. One is Prim's algorithm, second one is Kruskal's algorithm. Prim's algorithm is also used to find minimum cost spanning tree, right? So in this minimum cost spanning tree, one of the efficient method to find the minimum cost spanning tree. Minimum cost spanning tree is a subgraph that connect all the vertices in that given graph, the main graph with least possible edges and minimum cost. Let us consider one example. This is my graph, undirected graph. Total I am consider total how many vertices? 1, 2, 3, 4, 5, 6. Total how many vertices? 6 vertices. What is the weight of S to A? 12. S to B is 8. A to B is 9. A to C is 12. B to C is 16. A to E is 11. B to E is 14. C to E is 18. C to D is 15. E to D is 3. Okay, right? So in this example, my starting node is yes. I am consider root node is yes. So in this, yes, Find out the adjacent vertices of S. Total how many adjacent vertices? 2. One is S2A, another one is S2B. Total S2A 12. S2A cost is 12. S2B cost is 8. Which is minimum? 12 or 8? 8 is minimum. So consider this edge, add into the graph. S2B. What is the weight? 8. Next, consider vertex, newly added vertex. What is the newly added vertex? B. So find out adjacent, unvisited adjacent vertices of B. What are the adjacent vertices of B? B to E, B to C, B to A. So B to A, B to C, B to E. So remain in previous, another one is there. S to A is also there. S to A equal to 12. In among these 4, which one is minimum? So B to A is 4. B to A is 9. So add that edge into the graph. Already S to B is there, right? So add another edge B to A. Next, 9. What is the weight of that edge? 9. So which one is recently added node? A, right? So find out adjacent unvisited vertices of A. So A to C, A to B, A to E. All 3 is there, right? So A to C, A to B, A to E. In previously another node is there, right? S to A equal to 12. Okay. Among these 4, which one is minimum? So A to B already over, right? So don't consider this one. Already that one node is added, right? So next A to E. A to E is minimum. Next minimum is A to E is minimum. So add that edge into the graph, right? Next, find out unvisited adjacent nodes of newly added node. Newly added node is E, right? Find out unvisited adjacent nodes of E. So E to A is 11. That is already over, right? So remaining E to C is 18. E to D is 3. So E to C is 18. E to D is 3. Which is minimum among these two? 3 is minimum. So consider E to edge. That edge is added into the MST. So E to D. So weight is 3. Okay. Next. Newly added vertex is D, right? So find out unvisited adjacent vertices of D, right? So what are the adjacent nodes of D? So D to C is 15, D to E is 3. 3 is already visited, right? So we are considered 15. So C to D is 15. So D to C is 15. So here consider this one. So find out the minimum cost. 8 plus 9 plus 11 plus 3 plus 15 is 46. Total minimum cost spanning tree using Prim's algorithm of this graph is 46. Okay. Next, Kruskal's algorithm. It is also one of the minimum cost spanning tree algorithm to calculate MST, minimum cost spanning tree. So in this algorithm, step 1 is first write all the edges based on all the edges in which order? Ascending order. So if this is my graph. So in this, we are consider A to B, G to C, G to F, F to E, E to D, D to B. So like that we are considered totally 7 vertices. 1, 2, 3, 4, 5, 6, 7. 7 vertices. Each and every vertex, each and edge having some capacity, some weight, right? So in this example one, first step is sort all the edges based on which order? Ascending order. So first, ascending order means which order? Increasing order, right? So first 1 is there? No. 2 is there? No. 3 is there? No. Next 4 is there? No. Next 5 is there. So B to D. What is the weight of B to D? 5, right? So B to D weight is 5. Next, Is there any other 5s? No. Next weight is, minimum weight is 6. So consider next one is A to B. Next, any other 6s is there? No. Next 7. No. 8. No. Next 9. Yes. Next 9. Next C to F is 9. Next 9 is already over. 6 already over. 5 over. Next 10. 10 is there? Yes. E to F is 10. Next, is there any other 10s? No. Next 11. B to D, B to D, B to C is 11, right? So B to C is 11. Next, is there any other 11s? No, right? Next, 12 is there? Yes, G to F is 12. Next, G to F is 12. Next, is there any other 12s? No, right? Any other 13? No. The other 14? No. Next, 15. A to G is 15. Next, 16? No. 17. Yes, C to D is 17. Next, 18 is there? No. Yes, no. Next, 22. D to E is 22. Next weight is 25. Like that, we are sorting all the edges based on their weight. Okay, ascending order based on their weight. Next, construct the minimum cost spanning tree. Which one is minimum? So we are consider this one, B to D edge. What is the cost of that edge? 5. So consider that B to D cost is 5. Next, which one is minimum? A to B. A to B is 6. So next consider A to B. Why A to B we are consider? So cost is minimum. So next consider C to F. What is the weight of C to F? Next, C to F is, what is the C to F? C to F is 9. So consider C to F 9. Okay. Next edge is F to E. F to E. So F to E. What is the value of F to E? 10. So add that edge into the spanning tree. Next, B to C. What is the cost? 11. B to C. B to C is 11. Add that edge into the spanning tree. Next, G to F. G to F. G to F. G to F. F to G. F to G is 12. Right? Next, A to G 15. A to G is 15. For example, we are consider this edge into the MS spanning tree. It forming a cycle. Right? So discard this edge. A to G. Next, consider Z to D. C to D. So for example, we are consider this edge into the spanning tree, it forming a cycle. So discard this edge also, right? Next, D to E. What is the cost of D to E? 22. D to E. So D to E. For example, add into the spanning tree, it forming a cycle. So discard this edge also. Last one, C to G. What is the cost? 25. C to G. So C to G is C to G. So for example, add this edge into the spanning tree, this also forming a cycle. So reject this one. So totally diagram is A to B 6, B to C 11, B to D 5, next C to F 9, E, G 12, 11, 6, 5, 9, 9, 10, 12. So is it correct minimum spanning tree? Check. So in this example, total how many vertices? 1, 2, 3, 4, 5, 6, 7. So in our spanning tree, 7 minus 1 edges. 1, 2, 3, 4, 5, 6. Yes, it is the correct spanning tree. So what is the total cost? 6 plus 5, 11. 11 plus 11, 22. 22 plus 10, 32. 32 plus 9. 32 plus 9, 41. 41 plus 12, 53. Total MST value is 53, right? So these are the references. Thank you.